Hello students. In the last video we discussed about some of the kinematics parameters or the physical quantities associated in kinematics. Means we discussed about distance, displacement, velocity, acceleration, when this is velocity is uniform, when acceleration is uniform, all these things we discussed. Now in this video here we discuss the kinematic equations, the kinematic equations, we will discuss about the kinematic equations for a uniformly accelerated body. For uniformly accelerated body. So in this section we discuss about the kinematic equations for a uniformly accelerated body, for a uniformly accelerated motion or uniformly accelerated body. Means a body is uniformly accelerated, means it covers equal distance, it has the change in velocity, same change in velocity in equal intervals of time. That is the uniform acceleration. Already you know that. So for uniform acceleration means the change in velocity, the velocity changes at a constant rate with equal intervals of time. That is a uniform acceleration. And the other thing is that the body is moving in a straight line. So if you consider like that, then distance is equal to displacement and some other parameters are also same. So here that is not any difference between distance and displacement in this part, because for a straight line, a body is moving in a straight line, distance covered is equal to the displacement in a particular direction it is moving. So these equations are derived by considering a body moving with uniform acceleration in a straight line. That is the point. Clear? In this equation we will always consider like this. Now we will go for the this is also known as the equation of or motion. This is also simply called as the equations of motion, or you can say these are also the equations of motion. Okay, this is also known as the, or we can say these are the equations of motion. And I will derive these equations of motion or the kinematic equations for a uniformly accelerated body. Means this is, we can also say that the equations of motion is valid for a uniformly accelerated body. That is the point. Now in this part we will derive these equations by calculus method. What is calculus? Calculus method. What? Using the derivative and integration that we have already discussed. That's why we told that this integration derivative is required when you go for further studies. So that we will use here. What we read about integration, derivative, all these things that we use. Then you can ask, are the equations can be derived in other way? Yes, in other way we can derive. That is graphical method. By plotting the displacement time graph, by plotting the velocity time graph, from there also you can derive these equations of motion. Clear? But these equations of motion are valid for a body moving with uniform acceleration along a straight line. So distance and displacement is not so much changes. Okay. With this, now I will derive 4 equations. The first I will derive is velocity. First equation, velocity attained after time t. How much is the velocity attained by the body after time t? That first I will derive. Let me write what I am telling you all these times. Let a body moving with uniform acceleration. Let a body moving with uniform acceleration along a straight line. Along a straight line. That is the first stage. If you consider this, then we will derive the equations. Okay. Now, after considering like this, then we will go for the other thing is that For this, let dv is the change in velocity in time dt. Let dv or consider dv is the change in velocity in time dt. Change in velocity car? Which one? Change in velocity of the body in time dt. Let dv is the change in velocity of the body in time dt. Then if like that, acceleration is equal to, what would be the acceleration? Acceleration is equal to rate of change of velocity. So I am considering the magnitude part. Acceleration is equal to dv by dt. Clear? Then I can write dv is equal to a dt. Can you write? dv is equal to a dt. Let this is the equation 1. Right? Now we will go for the calculus part. So what is this calculus part means? We will put the what? Limits. Calculus means we will do the integration and put the limits. What this means? See. Here what we want to find? Velocity attained after time t. Here is the velocity in a time dt for the uniformly accelerated body. So I want to find what is the velocity attained by the body after a time t, for a long time t. So to make a smaller thing to larger, we do the integration. I told that in our videos while deriving these integrations and in the derivative and integration, in the discussion, in the calculus discussion, I already told that what is the use of this integration. Now we use this one. So you know this dv. So all of you remember this equation 1. Let me write again. dv is equal to a dt. This is equation 1. So now here you see, I want to find the velocity in a time t. So let us consider, again we will use here, let us consider this, when t is equal to 0, means when time is equal to 0, velocity is equal to u. This is called as the initial velocity. Generally u is taken considered as a initial velocity, right? Then when again this time I want to find in a time interval 0 to t, what is the velocity? So let this velocity is equal to b. That generally called as a final. Final means at t, this is the velocity, this is the limit. Now after knowing the limits, do the integration. So integrating to know the total velocity attained, integrating both sides with proper limit. Integrating both sides with proper limit. Now we integrate both sides. Put the integration dv, integration of a dt. Now put the limits. Here what is variable? dv changes from what? Initially u, finally b, lower to upper. Then when it is u, what is the time? Here time is variable, a is constant. So the limit should be, you should remember, for definite integral, in this factor, which one is variable? Time is changing, SLS is uniform. So time t 0, when u, velocity u, time t is equal to 0. When velocity b, time t is equal to t. So this is the limit. So do the integration of dv. Use this formula, integration of dx, x. When there is a limits, 2 to 3 limits, definite integral. This is indefinite. When the limits are there, definite. For definite integral, put the limits 2 and 3. Then upper limit, in place of this x, upper limit minus lower limit. So this is equal to 1. Clear? So this is the beauty of calculus. Clear? So like that, this formula I will use here. What is dv? That is b with limits u to b is equal to a. What is dt? T with limits 0 to t. So now with this limit again, we will do what? Put the upper limit in place of v, that is v, then minus upper limit minus lower limit v minus u is equal to a, put upper limit t minus lower limit 0. So this is equal to v minus u is equal to at or v is equal to u plus at. This is the equation of kinematics. First equation you can say the velocity attained by the body after the time t, if we know the initial velocity u and the body is accelerating uniformly in a straight line with acceleration a. That is the equation. Okay, this is the first equation of kinematics. Okay, now we will go for the second one. The second equation is the distance traveled, the second one, distance, or you can say displacement. Distance is because the body is moving with uniform acceleration in a straight line. Distance is equal to, you can say, displacement. Distance traveled after time t, after time interval t. How much distance it traveled after time interval t? After time interval t. What is the distance traveled, or you can say displacement traveled after time t? Do the same, write the same thing. Let a body is moving with an uniform acceleration a along a straight line. Okay, make this is a practice while doing the equations of kinematics. Okay, now for this, let ds is the distance traveled, or you can say displacement, distance traveled by the body in time dt. Clear? Then velocity is equal to what the formula? Instantaneous velocity. If we travel ds distance in time dt, then instantaneous velocity is what? V is equal to velocity, v is equal to ds by dt. Only consider the magnitude part. We are not going for direction because it is moving in a straight line. I have already in the beginning I consider that it is moving in a straight line. So in that straight line, everything is changing in that straight line. Then ds is equal to v dt. Then now from the equation 1, from the first equation of kinematics, v is equal to, if it is initial velocity u moving with an acceleration a in time t, v is equal to u plus at into dt. Or I can write this as a ds is equal to, you can multiply this each term, dt can be multiplied, plus at dt. Let this is my equation 1. After knowing this, then what we will do? I would want to find distance traveled after time interval t. So when put the limits, when t is equal to 0, time t is equal to 0, distance traveled, let me write like this, distance traveled 0. Got it? Then t is equal to t, distance traveled is s. What is this concept? Let me start this one. At time t is equal to 0, the body is at the point A and you are standing here, the origin. So s is equal to 0. After a time t, the body reach at B, so the time interval is 0 to t. When the body reach B, it covers a distance of s, and this is the displacement because the body is moving in the straight line. In a straight line, in uniform motion, distance is equal to the displacement. So that is the thing. So in time t, the distance traveled is s, that I have assumed. So when we got this one, then our next part is what? Integrate to know that total distance traveled. So integrating both sides, integrating equation 1, integrating equation 1 with proper limits. With proper limits. Put this with proper limits. Okay? Integrating both sides with the proper limits. Now if you with proper limits, then integration ds, then integration, make integration to each one, u dt, obviously this will be the integration, plus integration, or whole integration means integration will be by parts, integration of at dt. Now put the limits. Here what is variable? ds. So s changes from what? 0 to s. Here t changes from where? 0 to t in the time interval. Here t 0 to t. Because when time t is equal to 0, distance traveled is 0. Means it's starting from the origin. Now you can ask me, okay, if this is the body is at this position, suppose it is s1 and suppose this is s2. This distance s2. So what I will do here? I will put the limits accordingly. At time t is equal to 0, it is s1, it is s2. So put the limits like that. Okay, means it is not at the origin. The body is not from the origin. That is the frame of reference. You are standing here and the body is starting from there. Now do the integration. Is that clear? Try to make the concept clear. Clear? Otherwise it will be difficulty create difficulty for you. So make the concept clear when you are writing. So integration of ds, what that? S with limits 0 to s, u constant, because it is initially, what is the velocity? That velocity will be initial velocity. Then after that the velocity changes, but initial this is constant, u. Then integration of dt, t. Or okay, let me write like this, make it simpler, dt 0 to t. I am writing each step. And a, already you know it is uniform oscillation, a outside the integration, a constant can be taken outside the integration, a from 0 to t. Okay. Then this is equal to, put the upper limits, s minus 0, upper minus lower, is equal to u. Then what is dt? That is t with limits 0 to t, plus a, what is t dt? So now the integration of t dt, already you know the integration part, x to the power n dx is equal to x to the power n plus 1 by n plus 1. Is it? And with that there is a constant of integration. But we are not considering the constant of integration when there is a limits. When limits means suppose this is x1 to x2. If the limit is there, the constant of integration is not required here. So according to this formula, it has a limit t dt. So in place of x it is t, in place of n it is 1. So where there is x, put t, where there is n, put 1. So t dt means t 1 plus 1, that is t square by 2 with limits 0 to t. With limits 0 to t. Now solve this one, then you will get this is equal to, integrating this part you will find, put the upper, so now we put here s minus 0, s is equal to u upper limit minus lower limit t minus 0 plus a by 2 constant. So no need to, so this is 0 to t, so a by 2 I can write this as then t square, in place of t square first put upper limit, in place of t put t, that is equal to t square, t to the power square, minus in place of t put 0, that is equal to 0. Okay, already 2 is there. Then s is equal to, I can write u t minus 0 t plus half a t square. So this is the second equation of kinematics, the distance traveled after the time interval t. Clear? So after doing this second one, then we will go for the third equation of kinematics. The third equation of kinematics is, got it? Now we'll go for the third equation. The third one is the velocity attained after distance s. What is the velocity attained by the body after distance s? What its concept is? Now compare the equation 1 and equation 2. Their velocity attained by the body after time t. Here the velocity attained by the body after distance s. Where we will use these things. So try to understand that thing. Let us consider you are starting from your home, okay, moving with an uniform acceleration, starts from your home with a velocity u. Now if I will ask you after 5 hours or after 5 minutes, what is your velocity? You are starting from your home and you are moving towards the market. After 5 minutes, what is your velocity? That is the equation 1. Velocity attained after time t. But if I will ask after 5 kilometer, after traveling 5 kilometer, what is your velocity? In that case, we will use this concept of velocity attained by the body after the distance s. So here the distance means we can say that the body is moving in a straight line. So after this displacement s also we can say. Now for that, so initially the concept is same, but let the body is moving with a uniform acceleration a along a straight line. So let dv is the change in velocity in time dt. When I am writing this means for the body. So you can write this, let dv the change in velocity of the body in time dt. Then acceleration, then the acceleration a is equal to what we can write, dv by dt. Acceleration a is equal to dv by dt. Then from here your dv is equal to a dt. Okay. So before you, let me make a concept. Acceleration a is equal to dv by dt. What we want to derive? Velocity attained after the distance s. Means what is this velocity after a distance s? But there is no s factor, no distance factor. Acceleration, velocity, time. So let me make this a concept of making it into terms of distance, as you know in the derivative part. So dv by ds, let ds is the distance traveled in time dt. So dv by ds and into ds by dt. Can we write? ds get cancelled. Means what we can make? Here dy by dx can be written as dy by dt into dt by dx. That formula you know that. If y and x are functions of t, you can make that place. So dt get cancelled. So obviously this is dy by dx. I am making like that because distance factor is associated. That's why I am doing all these things. Okay. So that is the part. Then as you know, what is ds by dt? Rate of change of displacement, rate of change of distance, speed, velocity. So a is equal to dv by ds into b. That is the velocity. So here we can write this as a ds is equal to b dv. A ds is equal to b dv. Okay. So now here do the equation. So suppose this is my equation 1. So now I want to find what is the velocity attained after the time t. So now put the limits. Then time t is equal to 0. Then the time t is equal to 0. What is the velocity? Velocity is u. Velocity is u. And what is the distance travelled? 0 starts from initially distance travelled, because it travels from the origin. Distance travelled is equal to 0. Means this is the case, like let me show by a figure. At a, time t is equal to 0, s is equal to 0. This is the origin. And what is the velocity? U. When it reaches at b, u changes obviously b. Then how much is the distance here? S. The distance travelled is here s. And at a time t. So this time factor is not associated here, because we are finding velocity attained after distance s. Time factor associated in the equation 1. So I am not bothered about this time. So from s, travelling s distance, u changes to b. That is the point. So when time t is equal to t after the time interval, velocity is equal to changes to v, distance travelled is equal to s. Distance travelled is equal to s. So I made this changes from 0 to s. Clear? So this time factor is not required here. Now integrating both sides of equation 1 with limits. So let me write here integrating equation 1, integrating equation 1 with limits, with proper limits, what the limits you have used. So by using this one, let me write like this: a ds is equal to integrate b dv with limits. Now put the limits here. Ds is changing. How much it changes? From 0 to s. When ds changes from 0 to s, how much b changes? B changes u to b. Okay. So now using this one, a is a constant. So a integration of ds from 0 to s is equal to, what is b dv? Again use the same concept, x to the power n dx. X to the power n dx. Here x to the power n means b to the power n. N is 1. So this is equal to b square n plus 1 by 2 with limits u to b. Then a ds is s. Ds is s with limits 0 to s. This is equal to half. Put the upper limits, half outside. Upper limit in place of b square minus u square. B square minus u square. So now putting this one, a of upper limit is s minus lower limit is 0. So this is 0 is equal to half b square minus u square. Let me write this in simple way. As is equal to half b square minus u square, or I can write b square minus u square, multiply this to 2as. Okay, or b square is equal to u square plus 2as. So this is the third equation, that is the velocity attained by the body after traveling a distance s. Clear? So this is the third equation of kinematics. Okay. So now come to the fourth equation. So the fourth equation is the distance, or you can say displacement, distance traveled in nth second. Now this is the concept, nth second. What this nth second means? What is the distance traveled in nth second means? What it means actually? So the thing is that, let us consider you start from, try to understand the thing, from the point A1 at time t is equal to 0. So here reach at A2 in time t is equal to 1 second. How much distance you have traveled? This distance is suppose s1. You have traveled the distance s1. Clear? In time 1 second. Then at A3 the time t is equal to 2 seconds. How much is distance from this A1 from the starting point? Let you travel s2. Now let me ask you, what is the distance traveled by you in the first 1 second? First 1 second. How much? s1. What is the distance traveled by you in 2 seconds? s2. 2 seconds s2. But if I'll ask you, what is the distance traveled in the second in the second second? What is the distance traveled in the second second? This distance t1 to 2 seconds. In this part, this is the distance traveled. How much this is? s2 minus s1. Similarly, same concept is that, let the body is at a n minus 1 position at t is equal to n minus 1 second. So let this is the dotted line, it is up to move that. I find at a place a n minus 1 and the distance traveled at this point from a1, or you can make this a1. From here the total distance up to this is sn minus 1. Distance traveled is sn minus 1. Now it reaches at the point t is equal to n second. Then the distance is at another point an. The total distance from here it travels is sn. So what is the distance travel in n seconds? N seconds sn. What is the distance traveled in n minus 1 second? Sn minus 1. Then what is the distance traveled in the nth second? This distance. Now I will find this distance. Clear? I will find this distance. That is the concept. Clear? Are you getting? Yes. Okay. Now, got it? So I will now find this one. Means what I will do? I will make Sn minus 1. That is one way. But we are using calculus method, so I will use the integration part here. Okay. So let me allow to integrate. Let ds is the distance traveled by the body, in time dt, and obviously during whole path the acceleration is uniform and the body is moving in a straight line. Don't forget that thing, that is very, very important. So you will apply that uniform acceleration. Okay, because the derivations are like according to like this. That's why you are taking a uniform outside integration when you use the integration. Got it now? Okay. So let ds is the distance traveled by the body in time dt. Then velocity, instantaneous velocity v is equal to, we can take what? ds by dt. v is equal to ds by dt. Okay. Now as you know, ds is equal to v dt. Then ds is equal to what is v? U plus at. Already you know the relation. If it starts from u, here it is, suppose at t it is u. So u plus at is the uniform acceleration in time t into dt. Let this equation on. Let me make the calculus in different way. I will not multiply each term with dt. I will multiply when I do the integration part. Clear? It is up to you. Whatever you choose, you do the as you like. But the procedure must be correct. Procedure must be correct. That is important. Clear? Now, here put the limits. The limit part is here. Then time or t is equal to n minus 1. Time t is equal to n minus 1. Distance traveled. How much? How much? Sn minus 1. See your figure. Or if you have not take the screenshot, the previous one, then the distance traveled is what? Sn minus 1. When t is equal to n second, distance traveled, how much? Sn. Integrating both sides of equation 1 with proper limits. Integration ds, make integration both sides, u plus at dt. Now put the limits. What is variable ds? ds changes from where to where? S lower is what? Sn minus 1. Yes, Sn minus 1 changes to Sn. Here t changes from where to where? N minus 1. Then distance is this one to n. N minus 1 to n. Now do the integration. It is very much, now it is very much convenient to you to do the integration because already you have done so many integrations. So what is the integration of ds? S. Yes, S with limits n minus 1 to n is equal to, now this side what I will write like, see, u dt integration limit, yes, obviously n minus 1 to n plus at dt, multiply each term with integration n minus 1 to n. Already know that you can make the integration of u plus b dx, integration of u dx plus b dx integration of b dx, like that with limits. So now we put here, so this is not n minus 1, this is Sn minus 1, okay, this is Sn, the limits are Sn minus 1 to Sn. So now put the upper limit Sn, in place of S I will put Sn minus Sn minus 1, lower limit is equal to u, obviously constant, integration of dt with limits n minus 1 to n plus integration of a constant, let me take outside, a t dt n minus 1 to n. Got it? Keep this in your mind. Then this is what? Total distance in n second minus total distance covered in n minus 1 second. Total displacement in n second minus total displacement in n minus 1 second. That is equal to Snth. So I can take this as a Snth is equal to u dt is what? T with limits n minus 1 to n plus a. What is t dt? Yes, t dt. X to the power n dx, x to the n plus 1 by n plus 1. So t square n plus 1, t to the power 1, 1 plus 1 2 by 2 with limits n minus 1 to n. Clear? Right. Now this is equal to Snth. Remember, Snth means distance traveled in the nth second. U upper limit t, u in place of t upper limit minus of lower limit n minus 1. Got it? Plus, let's write a by 2 outside. Then t square n square upper limit square minus lower limit n minus 1 square t square n minus 1 square. Now you solve simple algebra, mathematics, and you are very much acquainted with your mathematics, right? This type of mathematics is very easy for you. Snth is equal to u, right, n minus n plus 1, yes, minus n plus 1 plus a by 2 n square minus, clear, a minus b whole square, a square plus b square minus 2ab, right? Then this is equal to u plus n minus n get cancel, u plus a by 2 n square minus n square minus 1 plus 2n plus n square minus n square get cancel. So I can write this is equal to u plus a by 2 2n minus 1, and what is here? Snth. So the distance traveled in the nth second is equal to u plus a by 2 into 2n minus 1. Got it, students? So my point is that by considering the uniform acceleration in a straight line, we derive the equations of kinematics. What are the equations? Again I will write. By combining all these things, let me make it in a nutshell that what we have derived the equations of motion or the equations of kinematics. Equations of motion are, let me write all these equations. The equations of motion or kinematic equations for uniformly accelerated body are, first we have derived v is equal to u plus at, isn't it? First one. Second I have derived that s is equal to ut plus half at square, distance traveled after the time t, velocity after time t. Third one, velocity after traveling distance, v square is equal to u square plus 2s, or v square minus u square is equal to 2as. Then the fourth one, distance traveled in the nth second is equal to u plus a by 2 into 2n minus 1. Got it, students? So these four equations we have derived, but in different cases, in different application, the application is also different. Suppose I will ask you, tell me the equations of kinematics when the body starts from rest. So for a body starts from rest, then u is equal to what? The initial velocity 0. For a body starts from rest, u is equal to 0. Now you tell me the equations of motion. Then first equation, velocity after time t, u plus at, u is 0, so simply at. Second one, s is equal to ut 0, u into 0, 0 into t plus half at square, so this will be half at square. Then third one, what is that? V square is equal to 2as if the body starts from rest, right? So then fourth one, Snth is equal to a by 2 into 2n minus 1. Means I am here, so my u is 0. Now I move some distance or travel some distance after time t. What is the velocity, what is the acceleration, what is the velocity, what is the distance traveled, all these things here we will use this equation if the body starts from rest. If the body has a velocity u initially, then we will use this equation. Then another question is, there is a concept called as your stopping potential. We are coming across the top, that is the stopping potential. What is the stopping potential? Now try to understand the stopping potential. Means not the stopping potential, that is a stopping distance here. Stopping distance. Sorry, I am telling you potential, it is stopping distance. What is the stopping distance? Now our body starts from the point A. You are at the point A and you are riding a motorcycle. Suddenly you saw a person is standing here on the road, a person is standing. You saw a person standing there. And you take a turn and you reach here and you saw suddenly this one. At that time what you will do? You will apply your brake. Applying brake means what? Your motion is along this direction. You are moving along this direction. When you see here, your velocity at this point is u. You have initial velocity is u. Because you are riding your bicycle. You are riding your motorcycle. So your velocity is u. Now you start from A and you see suddenly you see some person is or a child is standing in front of you at some distance. Then you suddenly apply the brake. What are you doing? Applying the brake means you are giving retardation. You are decreasing your velocity. You are retarding. Means you are applying an acceleration minus A. Can I say that minus A? Because your acceleration is opposite. In this direction you are applying the acceleration. Retardation, opposite acceleration. Because you are applying the brake, you are decreasing, velocity decreasing. Velocity decreasing means acceleration what? Negative. So now you come and when you apply that minus A, negative acceleration, then what are you finding? So when the acceleration is negative, you are applying the acceleration in this direction. Yes, acceleration is along this direction. Your motion is this direction. So that obviously the velocity will decreases. So there you stop, where this final velocity becomes 0, there you stops. There your motorcycle stops at the point P. So by applying the brake, you cover some distance because of this u. If you apply the brake here, the motorcycle will not stop there. It covers some distance. That is how much distance it covered. This distance to stop the vehicle by swinging this one. Before that it should be stopped. Otherwise it will make accident, right? So the stopping distance, I will cover the stopping distances. So where it stops means the final velocity is 0. So this concept is, as you know, v square minus u square is equal to 2as. What the velocity final? 0 minus initial velocity is u square 2. What is the acceleration? Minus A. Opposite acceleration, retardation, negative acceleration, minus A into S. So minus u square is equal to minus 2as. So minus minus get cancel. So S is equal to u square by 2a. This is the formula for stopping distance. This is the formula for stopping distance. Means after this distance travel, applying the brake and the vehicle stops. Before this and after this one. After seeing the object or the child and applying the brake, then before the vehicle stops, you have covered this distance. That distance is called the stopping distance. Means you stop the vehicle, you have this much of distance you have covered. From here you can say that this stopping distance is directly proportional to u square if the constant acceleration, right? Obviously you are at the retardation. So S is proportional to u square for constant acceleration, right? So S is proportional to u square means if the initial velocity is more, it requires more distance to stop the vehicle. That's why it is advised that not to rush drive. Go slow, drive slow. That is the physics we are applying there. Clear? Because it needs when you suddenly see something, then if you want to brake or you could stop the vehicle, then it will cover long distance because it directly proportional to u square. Okay, that is the beauty of your kinematic equations and applying these kinematic equations. Okay, students, now you go through this video and try to memorize all these things. Try to practice and go through these equations of kinematics. Okay students, thank you.